So in the previous video we have discussed about the refraction and refractive indexes, and in this video we will be discussing about the spherical lenses. So there are two types of spherical lenses, one is convex lens, another one is concave lens. So if you first see or look into this lens, that is convex lens, we can see that the ends or two ends of this one, you see here the two ends, this is a convex lens and here this is the top end, this is the bottom end. So two ends are thinner in compared to the middle portion. So and this middle portion will be like bulging outward and it will be thicker in compared to these edges or the ends, two ends, that is top end and bottom end. So it will be thinner, the ends will be thinner and the middle portion will be thicker. So it will be the description of the structure of convex lens. So it is a transparent object, through that we can see the things on the other side, and there will be a small reflection because it is there will be difference in the medium, because this side will be air and it is a glass, so there will be difference in the medium, so there will be refraction. So you can see things differently, but we will see these things later. So if you move the diagrammatic structure, so here you can see one so this is a convex lens. Similarly, this name of this lens is M and N, and two ends are thinner and the middle portion is thicker. And here if we see one point is there at the center, it is known as optical center, which is marked with O. And other than this point O, we have four other points. On the left hand side we have 2 points, on the right hand side we have 2 points. So on the left hand side we have a first point that is known as F1, and we have a second point that is known as 2F1. Similarly, on the right hand side we have a point that is known as F2, and another point we have that is 2F2. So we have these 5 points, one is optical center and 2 on the left hand side and 2 on the right hand side. So this F1 is the principal focus, and we have another focus that is double this focus, and it is also known as C1, and this is the second double focus, is also known as C2. So we have these 4 points, and if we move to this, the second lens, we have a concave lens, and this is our concave lens. One key difference is there, in the concave lens the ends are thicker in compared to the middle portion. So in the convex lens, what was there, the ends were thinner and middle portion was thicker, but here the ends are thick and middle portion is thin. Okay, so this is the difference. It is just opposite to this convex lens, and it is also a transparent object, through that we can see the things on the other side. And if we see the diagrammatic structure of the concave lens, we can see that we have the optical center, the middle, and we have 4 points, 2 on the left hand side and 2 on the right hand side. So in this picture the portion that images or the points that on the right side is not given. So on the left hand side we can see the first point is F1 and second point is 2F1. Similarly, on the right hand side we have a F2 and 2F2. Okay, so how we will give these points? We will put a scale at the optical center, same distance we will give one F1, and similarly on the right hand side we will at the same distance we will give the F2. So if it is O2, this F1 distance is 4 cm, we have to give this O2 F2 also 4 cm. If this O2 F2 is 8 cm, then from O2 to F2 will be 8 cm. So this distance will be same in both the sides. Okay, so this is all about the concave and convex lenses. Okay, next we will move to the rules for ray diagram of concave and convex lenses. Similarly, like concave and convex mirrors, here also we have to draw the ray diagrams for both concave and convex lenses. So before going into these ray diagrams, we need to know the rules for this one. Similarly, like mirrors, we have these rules here. We have 3 rules mainly. So first rule says that if a ray goes parallel to the principal axis, will pass through focus. If a light ray moves parallel to this principal axis after refraction, in that case, in case of mirror, what happened, and their reflection had taken place, but here refraction will take place because it is a transparent object. But in the mirrors it was not a transparent object, so the light ray reflected back, but here refraction will take place. So if a light ray moves parallel to the principal axis, after reflection it will go through this focus, or it will pass through focus. And in this case, in case of concave lens, if a light ray goes straight or parallel to the principal axis, after refraction it will go in such a direction that it will appear that it is moving to focus. in this convex lens, you see one thing, after refraction the light rays are converging at one point. So if in this picture you can see it clearly, so all the light rays which are moving parallel to the principal axis, after refraction all are meeting at one point, or all the light rays are converging at one point. So converging means meeting at one point. So this convex lens is also known as converging lens. And here you can see in the concave lens, the light rays after refraction are diverging in different directions. So they are not meeting at one point, so they are diverging. So the concave lens is also known as diverging lens. So one more thing we have learned here, one is convex lens are converging lens and concave lens are diverging lens. So here, so these are the two rules. So this is the first rule for convex and concave lens. Next we will move to the rule 2 or second rule, that is ray passing through focus will become parallel to principal axis. So if a light ray moves through focus, after refraction it will be parallel to the principal axis. Similarly here also, if a light ray appears that it is moving through focus, after refraction it will be parallel to the principal axis. So this is about rule 2. And next we will be moving to the third rule, that is if a light ray passes through optical center, it will go without doing any deviation. So if a light ray is going through optical center, after refraction there will not be any change of path, it will go straight without doing any deviation. So there will not be any deviation, it will go straight as it was going. So these are the three rules that we need to use while doing the ray diagrams for both concave and convex lenses.